Now we will today discuss about the distillation column, and in distillation column we will discuss about the Q line. Basically, it is the most prominent favorite question for the interviewer, which in every interview they ask about what is Q line. So basically, Q line is feed line. It is the basically so its formula is HV minus HF divided by HV minus HL. HV is the enthalpy of vapor minus enthalpy of feed divided by minus enthalpy of vapor minus enthalpy of liquid. So, if we in a physical way, if you talk about what is Q, so basically Q is the fraction of liquid in the feed, which you will just feed in a distillation column. You are feeding in a distillation column. So the slope is of Q line or feed line is defined as Q divided by Q minus 1, which will be equal to tan theta, which is equal to m. So, in other terms, you can say heat required to convert 1 mole feed to saturated vapor divided by molar heat of vaporization of the saturated liquid. It is nothing heat required to convert 1 mole feed to saturated vapor. It is this part Hv minus Hf. Heat required to convert 1 mole feed to saturated vapor, this part. And mole heat of vaporization of the saturated liquid Hv minus Hl. So when your feed, which you are feeding in a distillation column, is a saturated liquid, that is HF. If your HF is saturated liquid, then your HF is equal to HL. Your HF will be equal to HL. So once it will become HF barabar HL, then HV this factor will become equal to this factor. The value will be Q is equal to 1. Once it will be 1, then 1 divided by 1 minus 1, that is 1 upon divided by 0. 1 divided by 0 is equal to infinite. 1 when tan theta is equal to infinite, then it means theta is equal to 90 degree. So when you plot the graph in a equilibrium curve y and x, here y is the mole fraction of the vapor of more volatile component, and it is a mole fraction of more volatile component in a liquid phase. So it is a diagonal line. This is the equilibrium curve between y and x, and q barabar 1. When you draw the line q equal to 1 like this, it will start from except like this. One, when your feed will be saturated vapor, that is this HF is equal to HV, then this whole term becomes 0. HV minus HV barabar 0, and 0 divided by something is equal to 0. Then slope q is equal to 0. 0 minus divided by 0 minus 1 is equal to 0. Tan theta is equal to 0. It means theta is equal to 0. When theta is equal to 0, then we q barabar 0, we will draw the line from except and except from this point like this. This is a q is equal to 0, and this is a q is equal to 1. We have already studied about it. So, and when our feed is a two-phase mixture, it is like in a liquid, also in a some vapor phase. So when we talk about the two-phase mixture, then your liquid phase will become between 0 to 99%. It may be anything, and your or in other terms, you can say your vapor or liquid. This will become 0 to 99% in any ratio, like two-phase mixture. In two-phase mixture, vapor will be present, and also a liquid will be present. So when you will draw the graph in equilibrium curve, 0, 0 to 1, then it will come like this. And when you will draw about the subcooled liquid, So in case of subcooled liquid, HL greater than HF. This term always be greater than HF. So this whole value will be greater than 1. Once it will be greater than 1, 1 divided by, so it will comes something between 0 to 90, between 0 to 90, tan theta. So you can try in a first quadrant, Q is greater than 1, Q greater than 1. So this part will come like this, Q greater than 1. When your feed is superheated vapor, then Q less than 0. Why? Because HF, your HF greater than HV, because it is a superheated, then HF greater than HV, then it will, the term become negative. Q will become negative. So it will come in a third quadrant like this, Q less than 0 superheated vapor. So basically this is a graph between temperature versus composition. Here is the X is equal to 1, here X is equal to 0. So it is a pure component, like a more volatile component. Here temperature is Ta, because it is a more volatile component, so boiling point will be less. And in other side, this is a Tb. So it is a less volatile component. Here it is a only a material present in this graph. So when we draw the graph, so below this point, all the portion is a subcooled liquid. Is a subcooled liquid, and this graph shows the saturated liquid. It is also known as a bubble point curve, and this graph is known as TV. Between TV and TA, it is the saturated vapor, also known as dew point. Above this curve, it is a superheated vapor, and between these two graphs, liquid and vapor mixture exist. Liquid and vapor mixture exist. Hope now it's clear to all of you the Q line, about the Q line and Q line equation.